All right, welcome back. And now we're going to look at example 2 and 3 in our section 1.6. So more about functions and how we can interpret them. So for this problem, they are going to be giving you a function. In this case, it's a piecewise defined function. And they want you just to identify the different function values as listed. So let's just jump right into all these. So we want f of -5. So f of -5, so we have to first just figure out which branch we're in and then plug and chug. So -5 is going to have to be in this first top branch because it's less than or equal to -1. So all we need to do is just multiply 2 times -5, which is -10. Done. So for b, we want f of -1. So now -1 is going to have to still be in that top branch because it's less than or equal to. So 2 times -1 is -2. F of 0. 0 now belongs in the second branch because it's greater than -1. So 0 minus 1 is -1. And then last but not least, f of 3, which also is in the bottom branch. So 3 minus 1 is 2. Easy peasy. All right, let's try the next one. Same inputs. So f of -5. So let's see, where are we going to go? Which branch? Looks like this first one because it's less than -4. So 2 plus a -5 would be a -3. F of -1, let's see, -1 belongs, looks like it belongs in this middle branch, right? It's between -4 and 2, so we just have to negate x. So be careful, those negatives. So we'll get a +1 from that. F of 0, 0 also belongs in this middle branch. So, well, it doesn't make sense to make a -0, so we'll just call it 0. And then D, f of 3. So 3 is in that last branch because it's greater than 2. So 3 times 3 is 9. Done. Now, the one thing you want to be careful with these problems is, don't just blatantly plug the input into each branch and think you need 2 answers or 3 answers in this case of the second one. There's always just one branch that should satisfy. So you got to look at which inequality is going to be the one you want to use. And then you plug it into the appropriate piece of that function. Okay, so those are individual values, but what about the actual whole graph? Sometimes that can be a little bit tricky, but you're still kind of doing the same thing. You're still just looking at specific points, and then you kind of extrapolate from there. Now, looking at our first function, we know, based off of our previous looks at those parent functions, that these are both constants. So that we know they're going to be horizontal lines, but we just have to be careful where they're defined based off of these inequalities. So the first branch looks like 2, but only when x is less than -1. So at -1 is where there's a change. So at -1, let's not start exactly there. Let's work our way from left to right. So we know that it's a constant 2 all the way through here. And then when we get to -1, the $1,000,000 question is it a solid dot or an open dot? So remember, the inequality is just a strict inequality, so that means it will be an open dot here. So that should be that part of the graph. Now for the second part, it looks like -2, but now it's when x is greater than or equal to -1. So now we're dropping down below the x-axis. And again, let's not worry about what's happening directly at -1 here. Let's just kind of skip it and say, okay, well, we know that this is all going to be a horizontal line here. So just to kind of fill it in a little bit. And now, do we want a solid or an open dot here? Well, now we do have a greater than or equal to, so we do want a solid dot. So again, those inequalities are very important in determining whether or not you have solid or open dots at just those transition spots. So -1 is a transition spot. So we got to be really careful what we are showing in our graphs there. Now this one's a little bit more complicated, but we have a quadratic, so we got to kind of, be careful with that. We will plot some points just to get the picture, and it looks that way between -2 and 2, including -2 and 2. So that's kind of nice because remember, we can use solid dots on those endpoints. So let's start right at -2 and see what we get. At -2, if we plug that in, we square it, we get a +4. 4 minus 4 is 0. So we'll put a solid dot there. Now, the one thing you should notice here is that we don't have 3 branches. So we have, between -2 and 2, we have greater than 2. We don't have less than -2. We don't have anything over here on this part of the graph. But that's just the way it is. So there's nothing there. But let's keep going. -1, it's going to point to 3. 0 should point us to 4. And we can start to see our quadratic taking shape. So we can sketch in our graph for that piece of the function. And now we have x minus 2 if x is greater than 2. So we know it's got a slope of 1 and a y-intercept of -2. So it would normally intersect down here. But we've already got the function defined in this part. So we're just using this for reference. So we can kind of see our line is going to be going up through like this. Now, what's nice about this problem is that we can see that it passes through this point as well, which is a bonus. So we don't have to worry about an open dot anyplace because it's falling right on the spot. So we can just sketch our slope of 1 on through, and let's just erase that so we don't make a mistake. So that should be our piecewise function. All right, and that wraps up this section. So we're going to get into 1.7 next videos, which is all about transformations. A lot going on in that section. So stay tuned for that.